Today's lesson is on z-scores. So a z-score is a standardized value that indicates the number of standard deviations of a data value above or below the mean. So in your notes, it seems like there's a really wonky formula. This is not correct. You're going to want to scratch that out with a pen, pencil, whatever you got, and you're going to want to write the following. It's not as weird as that one. So z is going to be equal to x minus your mean divided by your standard deviation. So whatever your data value is minus your mean divided by your standard deviation is going to give you what we call a z-score. So a standard normal distribution is a normal distribution that has a mean of 0 and a standard deviation of 1. So let's take a look at an example. I'm going to also preface this with the fact that you're going to need the back of your textbook. There is some charts. Pretty sure they're on page 592 and 593. You might want to have those open about now. So if you don't have your textbook beside you, you're going to want that. So I recommend you go grab that. So pause the video, go grab that, and then come back and we can get started. So example number 1 states that Joe got 2 math exams back on the same day. On the first test, the mean was 65 and the standard deviation was 8. On the second test, the average was 41 and the standard deviation was 57. So important information so far is that the mean of the first one was 65 and it had a standard deviation of 8. The second one had an average or a mean of 41 and a standard deviation of 57. Now, Joe's marks were 77 on the first test and 57 on the second test. So we got 57 on the second one, 77 on the first one. And it wants to know which of his marks were better relative, so in comparison to the rest of his class. So what we're going to do is we're going to find the z-score for both of them, and we're going to compare those scores. So for the first one, we're going to say that z is going to be equal to my x value, which is going to be what he got on the test, so 77, minus the mean, which was 65, and divided by our standard deviation of 8. So if I type this all into my calculator, I get 1.5. So this means that it's 1.5 standard deviations from the mean. Now, test number 2, the z-score for test number 2 is going to be as follows. He got 57, the average was 41, and the standard deviation was 57. So if I take these, go 57 minus 41 divided by 57, I get 0.28, 0.070174. With standard deviation, we like 3 decimal places. So in this case, it's 0.281. We need 3 decimal places for z-scores. So when we're looking at it, we're going to say you might not have thought test 1 was the better result because he got a lower mark, but in comparison to the rest of his class, he actually did much better. And the reason being his z-score is lower on test 2. So that means that in comparison to his classmates, he did better here because he's not 1 full standard deviation away. He's 0.281 of a standard deviation away, whereas over here, he's 1.5 standard deviations away. So this one here is actually the test in which he performed better on when compared to his classmates. So now's when you're going to need those pages out of your textbook because we're going to take these z-scores that we know how to find now and we're going to use those tables to figure out percentages. So IQ tests are something given to measure a person's intellectual capabilities or capacity at a particular time. IQ scores are normally distributed, which means it has a mean of 100 and a standard deviation of 15. So if a person scores 126 on an IQ test, what percent of the general population scores below them? So what we're going to do is we're going to calculate our z-score, and then we're going to look that z-score up in the tables on page 592, 593. And that's going to give us a percentage. Anytime you have a z-score, it's a percentage of information below your set point. So it gives you a amount under a curve. So in this case, here we go, say this is 120, 100 here. So this is 100. 126, let's say, was here. That means that this here, the percentage we're looking for, is the area under the curve to the left of that data point. And the percentage I'm going to get from my z-score will always give me the percentage to the left of whatever z-score I put into it. So in this case, we're going to figure out our z-score. So we're going to go z is equal to x, which in this case is 126, because that's what we scored, minus the average, which was 100, divided by a standard deviation of 15. So in this case, I'm looking for a z-score of 1.73 repeated. So 1.73. So what we're going to do is we're going to go, you're going to look at your textbook and your chart. You're going to look at page 593 because that's what contains the positive z-scores, and those are the ones we want. So what we're going to do is we're going to find along the vertical axis, we're going to find 1.7. So now that I have 1.7, it's right here. I'm going to go all the way across until I hit 1.73, and then I can stop. So 1.73 gives me a number of 0.9582. So what I can do is I can take that number, and I'm going to go back to this example here, and we're going to be given the following. So I know that z is equal to this, gives me the following. It gives me 0.9582. Now, to figure out what percentage that is, I'm going to multiply whatever that score is by 100. And that's going to give me 95.82%. Leave the decimal percentages, okay? Don't get rid of them. Leave it as 95.82%. This tells me that 95.82% of the population has an IQ lower than 126. All right, so our next example says that athletes should replace their running shoes before the shoes lose their ability to absorb shock. Running shoes lose their shock absorbency after a mean distance of 640 kilometers. With a standard deviation of 160 kilometers, Stewart is a recreational runner. He plans to replace his running shoes when 70% of people would replace their shoes. So in this case, we're given the percentage. And since we're given the percentage, what we're going to do is we're going to turn that percentage to a decimal. So I'm going to go 70 over 100. It's going to give me 0.700. Now what we're going to do is we're going to go to our table, and we're going to do things a little bit differently. We're now looking for 0.7. So find 0.7 on here. And when we can find 0.7, we're going to find the things closest. Sorry, I should repeat that. Things closest to 0.7. So we're going to find the one above and the one below 0.7. So I found 0.701. So here's the one above, and this is the one below. And so since we're looking at this, I have 0.6985 and 0.7019. So since I have those two data points, what I'm going to do is I'm actually going to take kind of the middle part of those two things. So they kind of sit in the middle of those two numbers. So when we looked at the chart, we found those two numbers. So it was at 0.50, 0.52, and 0.53. So when we go and write this, we actually can write it as, I have something between 0.52 and 0.53. So we're going to approximate it as 0.525. We're just going to pick that middle number. It's a decent number. It's okay. If you have it between two and it doesn't fall exactly on one, just take the lower one and add the 0.5 behind it, and it will even out in the end. So then now what we can do is we know the z-score. So the z-score is going to be 0.525. And now what we're going to do is we're going to set that equal to our x value, which we don't know. We're actually looking for x. We do know the mean. Yes, we do know the mean. So the mean distance is 640. So we're going to minus 640. And we're going to divide by a standard deviation of 160. So now what we want to do is we want to manipulate our equation to solve for x. So in this case, I'm going to multiply both sides by 160, and it's going to give me x minus 640. I'm then going to in turn add 640 to both sides. Okay, so if I go 0.525 times 160 plus 640, I'm going to get 724 is equal to x. So this tells me that this athlete here, Stuart, who's a recreational runner, is going to want to replace his runners at 724 kilometers, at approximately 724 kilometers of use. So that's when we're given a score, how we can find out a number from that, or vice versa, if we're looking for the Z-score, how we can find a percentage. In this example here, the company produces bungee cords, and the length of bungee cords produced are normally distributed. So in order for Z-scores, we have to have a normal distribution, or it's not going to work super great. So with a mean of 45.2 and a standard deviation of 1.3. The bungee cords that are shorter than 42 centimeters or longer than 48 are considered rejected by quality control. And it wants to know what percent of bungee cords are accepted. So in this case, we actually have to find two Z-scores. We need to find a minimum. So in this case, the minimum was 42. And we need to find a maximum, which in this case was 48. And then we have to figure out the area between the two. So let's find our Z-scores first. So in this case, I'm going to have 42 minus 45.2 divided by 1.3. And it's going to give me negative 2.461. And on this side here, I'm going to get a Z-score of 48 minus 45.2 over 1.3. And it's going to give me a 2.153 Z-score. So now what we're doing is we're going to take those numbers, we're going to look them up on our chart. So when I go over here, I'm going to look up negative 2.461, so 2.4, I missed it, sorry, 2.46. So this one right here is 0.0069. So we're going to go and we're going to go back here and we're going to write the fact that we have, in this case, 0.0069. Now I want you to take a look at your textbook. I want you to look up the next score of 2.153, so 2.15 in your textbook chart and tell me what you get as a Z-score. So you should have gotten 0.0158 as your number. And what this tells me is if I was to draw a nice little picture here, I have something that's here and something that's down here. I want this area here, but the Z-score for this one gives me all of this, and the Z-score for this little guy here gives me just this. So in order to find just the middle between the two, what I'm going to do is I'm going to take the bigger one, which gives me everything to the left of that number, so everything to the left of this, and I'm going to subtract, sorry, give me 1 second here. Sorry, I misread the question. It's asking us, my bad, I'm going to re-explain this to you. It's asking us for which percent are accepted. So in this case here, anything longer, so anything to the right of this is rejected, and anything to the left of this is rejected. So I need to figure out what this area is. This number here gives me everything to the left of it. So if I take it and I go 1 minus the 0.0158, it's going to give me everything to the right of that, which is what I want, because that tells me how many were rejected. This tells me how many were rejected. So now I want to know how many are accepted. So if I figure out the right value, I can add the two together, and the middle part is what's going to be my accepted value. So when I'm looking at this, I get 1 minus 0.0158, and I'm going to wind up with a number of, oh, sorry. This number is when you subtract it. So you should have actually gotten a number of 0.9842. And if I want to figure out the amount to the right of that, so I can add the two together, it gives me an amount that is not going to be done. I'm going to go through and I'm going to go the 0.9842. I'm going to subtract that from 1 and I'm going to get the 0.0158 that I was talking about before. So if you didn't know where that came from, that's why. Now we have this number and we have the other number here. What I can do is I'm going to be able to figure out the percentage of bungee cords that are rejected. So if I want to figure out the percentage that are rejected, I'm going to take the two percentages here. So the 0.0069, add it to the 0.0158. And then what I'm going to do is I'm going to multiply this by 100, and that's going to give me a percentage of 2.27%. So this is the amount that are rejected. If I want the amount that are accepted, I'm just going to take 100, subtract the 2.27%, and I'm going to get 97.73% are accepted. 97.73%. Now, if you wanted to know what that was as a whole number of total bungee cords, if it gave you a total number, you just multiply by the percentage and it would divide by 100 and it would give you an exact amount of bungee cords. So in this case, 97.3 are accepted. All right, and in our last example, it says a manufacturer of iPods has determined that the mean life is 32.4 months with a standard deviation of 6.3 months. What length of warranty should be offered if the manufacturer wants to restrict the repair to less than 3%? So what we're trying to do is we're going to have to take that 3%, turn it to a decimal, so 0.03. In other words, we divide it by 100. And now that we have that, I am going to be able to take my chart and I'm going to look it up in my chart. So we're going to go over to our chart here. We're looking at 0.03. So 0.03. Here we go. 0.03. This is the one above. This is the one below. So I'm going to have negative 1.89 and negative 1.88 as my two numbers. So that gives me negative 1.89 and negative 1.88. So approximately a Z-score of approximately negative 1.895 or 885, sorry, not 895. Should be 885. Here we go. Of 885, because this one here gave me a bigger number, this one gave me a smaller number, so the in-between should get me to where I need to be. So now that I have that, what I can do is I can go negative, I can use my Z-score thing, so where it's Z is equal to X minus X, the mean over my standard deviation. So in this case, Z is negative 1.885. X is what we're looking for. My mean in this case was 32.4. And my standard deviation was 6.3. So we're going to multiply negative 1.885 by 6.3. Going to give me X minus 32.4. And then we're just going to add 32.4 to both sides, and we're going to get a number of 20.5245. So if they wanted to keep it under 3%, they're going to have approximately a 20-month warranty in order to keep it under that 3%.